I mean, I had other plans for the evening, but I need to report on this. Hello and welcome to another Solana success story. Today, we're gonna talk about block times, and then we just decreased block times on mainnet by 50 milliseconds. 50 milliseconds, ladies and gentlemen. So we're at 350 milliseconds per block. Target time. In theory, in practice, it's gonna be a little more, but in practice, it was also a little more than 400 milliseconds. So the 50 milliseconds improvement, I think that's the correct thing to say. But why this is so cool, what that means for us, and why I'm so excited about it, let's talk about that. Let's talk about block time reductions. Look at this. 357. 8. That's the current block times on Solana mainnet. You can check this page at solana.com/200ms because 200 millisecond block times is the end goal. But you gotta go there incrementally. That's what we're doing with this incremental decreases, because obviously that decreases the likelihood of something going catastrophically wrong. And we have a great track record of not getting it catastrophically wrong in the past 3 years. So this is good. This is good. Check this. I'm excited about that. What a cliff. 12 hours ago, we were chugging along with 410 milliseconds. And now, boom, we're at 360. That here, ladies and gentlemen, is a feature activation. Or should I say, a feature becoming active. Isn't that the same thing? Not quite. Technical details that we can go into because this is a technical tutorial. Still, I love talking about the technical stuff, about all of that. That's why we're not gonna stay here on this dashboard, even though I love this dashboard and I really like looking at it. Now that we have 350 millisecond block times, this is exciting. I love it. Fire Dancer even goes faster because they don't care. Anyway, nice dashboard. Could keep looking at that for an hour or so. And we'll come back to that. But let's go somewhere else. To our trusted explorer. Because also here we will see that current block times are at the 300 millisecond area. 366, 365. Pretty consistent also over the 1 minute and 1 hour average. What can I say? Welcome to epoch 1020. This is the epoch after 1019, which is where this feature gate got activated. And that feature gate is reducing slot times to 350 milliseconds. SIMD 525. Let's go check that out. This was proposed 3 months ago and it does have feature gates. Look at that. Each of the ones have their individual feature gate, all starting with IBRL. What does that stand? I'm sure there's a reason behind that. It's not obvious to me though. IBRL. If you get it, tell me in the comments. And what this SIMD proposes is to reduce Solana's target slot time from 400 to 200 milliseconds in 4 steps. Step 1, 350, which is what we're seeing today. Yeah, that's 12 hours. I totally get it. So let's get a little bit technical, because I'm a nerd, because we want to understand what that means. The first question that I asked myself was, hold on, wait a second, does that mean epochs are getting shorter as well? And the answer is yes. Not shorter in amounts of blocks, but shorter in time. Because epochs keep their fixed size of 4320 slots, and that was 2 days at 400 milliseconds. Now at 350 milliseconds, that's a little bit less than 2 days, and at 200 milliseconds, that will be 1 day. So in the end, we'll end up with 1 day epochs, which also means faster feature activation. Cool. The per slot work limits are reduced in proportion to the target slot time, so the corresponding wall clock rate remains approximately unchanged. Wait, work limits. You mean like the CU per block? Oh, I was hoping that we can just peg twice as many transactions now. We'll see. Slots per year is obviously then the inverse of that ratio. Yeah, that makes sense because faster slot times and milliseconds are part of the year, so you literally have to do that. That's not a possible decision. No, slots per year stay the same, but block times go down. That's not how this works. And apparently nothing changes for Alpenglow, because they adjust those whatever limits. Not like I understand Alpenglow, so we're gonna ignore that for now. And this is an important fact here as well. Each feature gate becomes effective 1 epoch after activation. That's why we saw this activation. That epoch started already, well, 2.5 days ago. But the next epoch, or epic, the one in progress, this one started today at 7 in the morning, UTC. And that's what we saw earlier here when it was actually reporting 12 hours. Anyway, we saw it earlier. We still saw it. We were early or something. So 12 hours ago, we started getting faster blocks because at that epoch boundary, the feature got actually activated. Or how do you say, the feature became effective on epoch after it got activated. This is so Turbine can cleanly apply the reduced shred limits. Yeah, you go Turbine. Do some more work before you get replaced by Alpenglow. Good. Why did we do this? And when I say we, it's obviously I didn't do anything here, but the Giga chats at Solana. Shorter slots reduce confirmation and finalization latency, which means now with shorter slot times, you get your finalized commitment quicker. And also they're confirmed. So you can more quickly confirm and finalize blocks. That's also good for the devs, because that time will basically half when block time halves. That's how that works, because the limits stay the same. A finalization is still 32 blocks after the block got built, while we're not doing Alpenglow. With Alpenglow, all of that changes once again to be even faster. So yeah, so everything measured in slots takes less wall clock time. That makes sense. Then keeping the leader span at 4 slots also shortens the wall clock time duration for every single leader window. That's true. They had 4 times 400 milliseconds and they will get 4 times 200 milliseconds. So from 1.5 seconds, they now get less than a second to produce their blocks, where a single leader is in control, which is also good, because if one happens to be down, then we recover faster. This improves market structure by reducing the worst case time a leader can delay, reorder, or selectively include transactions before the next leader has an opportunity to produce a block. Yeah, market incentives. Let's go. Then, shorter slots also provide a finer grained on-chain understanding of time, which, you know, is good for oracles. Market makers can make decisions with a smaller slot time quantization error. Yeah, I mean, there is the clock sysvar, but obviously, if we're throwing out more blocks, then we can have a finer grained analysis. It's quicker, basically, is what that's saying. Whatever. I'm too excited to be technically correct here. The staged rollout is intended to discover timing, implementation, and operational problems. That's why we're not jumping from 400 to 200, but we're rolling it out. I still say we. They are rolling it out in increments or decrements, depending on how you see it. That's pretty cool. And we don't need to mess with the leader or epoch schedule. Okay, we already said that about the slots per epoch stay the same, but SIMD 357 charges the admitted validator per epoch. So that's why they're scaling that to a different target, such that the daily Alpenglow validator admission cost is unchanged. Okay, good. We'll get 5 feature gates. We already have them. We saw them up there. Here, they already decided. And the detailed design. Okay, I don't think I'll go over all of that. We kind of touched on those things. Features get deactivated late, 1 epoch after feature become active. And the timing values, those are interesting again now. Now we have the feature gates. And at those times, an epoch is 48 hours with that many slots per year. And currently, we're at 42 hours per epoch. So this epoch 1020 will be the shortest epoch in Solana history. And then all the other ones will be as short, and then they will be even shorter. But I want to re-emphasize that this is the first time in Solana history that we changed block times on purpose. They changed by the amount of load in the network and stuff. But we decreased it on purpose for the first time ever. And then we're gonna do it again and again and one more time. Wait, that would be 4 times. Yeah, 4 times. That makes sense. This is impressive, because after all those 4 changes, we'll have epoch times of 24 hours. A single day. And leader spans of 0.8 seconds. And the tick will be that many nanoseconds, which I have actually no idea what that is, but it's half as much as it was before. What's a tick? I can probably calculate that. Hold on. Because here we have nanoseconds per slot. That many divided by that many is 64. So 64 ticks make up one slot. Do I know what a tick is? I have no idea. This is probably a validator internal timing thing. But yeah, also those times go down. A fundamental cryptographic ledger entry in the proof of history stream. There we go. Knew it. Timing. Proof of history timing thingies. There we go. A collection of 64 ticks makes up one slot. Solana's basic unit of time. Yeah, great. Okay, learn something. That's what a tick is. I might have different ticks as well, but moving on. Yeah, that's Alpenglow stuff. Not interested. The scaled per slot values. Yeah, now it gets interesting. Because that's what I was curious about, if those limits now also stay the same with the block or if they get scaled to stay the same with the time. Let's look. But that's validator internal stuff. You could have put those here. It's not like there wasn't space, but okay, whatever. Right, so some values, they are now scaling. So hashes per tick, you can only do half as many in the end, because the tick gets faster. So this stays the same with time. Okay. But yeah, those are the interesting ones that I care about as a dev. The maximum compute units per block, they also get halved. Okay, so we're not getting more CU overall. We're not getting more throughput in that sense in the total compute that we can have per time. That stays the same, which means also the total number of transactions that the network can handle stays the same, given the same size of transactions and whatever. Which means the blocks will now just be packed more sparsely. So that's an important distinction. We're not just doubling block time and therefore doubling how much we can handle, how many transactions and how much compute we can do, because that also scales with it. That also halves and therefore cancels out with the block time increases. Okay, good to know. At least they mention that. There will be separate proposals that change that. And in fact, we did change that already and allowed more CUs per block. Evolved from 48 million to 100 million CUs. That already changed once. When did that change? July 2026. Not that long ago. SIMD 286 increased block limits to 100 M. So we started out with 48, then they were 50, then 60, now 100. Although actually I don't know if that SIMD already got accepted. And there they did a similar thing. They first increased it a little bit to do some testing and then they increased it more. Or wait, they will increase it. No, they did increase it more because that activation was 2025. And so a year later, now in 2026, we should already be at the 100 M. So they did increase this. Now changing the block times does not increase this again. That was the feature gate. And we reached that not too long ago. Let me quickly just double check. This feature is active on mainnet. Yeah. Okay, anyway, that was a side quest. But it's good to know that that doesn't change. Just you're not misinformed. I'm just trying to be a good boy and give you the accurate information, not hyping everything. Even though I am pretty hyped about that, honestly. Look at that. And we're gonna do 3 more of those. That'd be amazing. Why do I get excited about shorter block times? I don't know. I just do. Same way I'm getting excited about Alpenglow, and I will be sitting here making a video being like, oh, Alpenglow is live. Isn't that amazing? I'm now sitting here. Isn't it amazing that we have 350 millisecond block times? Pretty amazing. Okay, runtime changes. This is a big document. Maybe I don't want to go through all of it, but yeah, that's implementation details. Notable non-changes. We intentionally don't change. I keep saying we, as if I worked on this. I'm reading it from their voice. The leader span, so it's still 4 slots per leader. It's still 64 ticks per slot. It's still 432,000 slots per epoch. And Solana clock and SDK constant values remain unchanged initially. Okay, grace ticks, whatever that is, but they're not changing it. Timely vote credits grace, not changing that. The repair delay including the 250 milliseconds repair defer threshold. So that apparently also doesn't scale. Vote transaction costs don't change, but that means that we're now paying more for vote transactions in the same amount of time, I guess, right? Validators have to pay more, but they will also be rewarded more / the same. Like there will also be more rewards. Wait, that also means that changes inflation, right? Because if we produce more blocks, there will be more block rewards, therefore higher inflation, right? I think so. Which reminds me to tell you, stake your soul. Otherwise, inflation is literally eating your pocket or something. It's not like I have staked my soul, but I want to be a good boy and tell you. Blockage and queue, yeah, whatever. Gossip, default millisecond per slot, heuristics, okay. Edge cases. Activated at Genesis, it's not effective until 1 unless Genesis explicitly defines the reduced target as the baseline. Right, that's fun actually. So if you start a local test validator, then it will automatically, with all features enabled, the first epoch it will run slower than the rest. I guess so. Let's do another Solana test validator and check the features for IBR. Look at that. They're all active here in this test validator, but I have no good way of actually taking times. So gossip, inflation. I want something with slots per epoch. Oh, that's nice. Can also change the ticks per slot, but let's do slots per epoch. So on test validator, slots per epoch 64. There's going to be short epochs. So let's check, and we're counting the slots 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And so that kind of, yeah, 20 seconds, 40 slots. Kind of sounds like 400 milliseconds. Now look what happens here. Did it just increase the speed? Did you see that? Did it just increase the speed? It did, right? I'm not imagining this. It literally did. 2, 4, 5, 6, 7. Yeah, now I can't count this anymore. Now it's faster. This is fun. So basically, it doubled the speed at the epoch boundary, the local test validator, because that's what the code specified that it should do. Because after epoch 1, it will go to the reduced target. Fun times. It won't do that if I would disable the feature set, but this is something that you can try at home if you want to. Okay, cool, great. We demonstrated an edge case. Amazing. Good enough for that. Validator components. I don't even know how the validator works, so I'm not going to look at that. They did consider increasing the slots per epoch to keep it at 2 days. They also considered changing the slots per leader span to keep the leader window at the 1.6 seconds. So for instance, then they would have 8 slots. But there, even I would say, no, it's actually better if you change leaders faster. That's what I would want. So, and if we keep it the same, then we don't need to introduce changes to the leader schedule. So that's good. Yeah, they also considered to reduce the slots per leader span while keeping the 400 millisecond blocks. So removing them to 2 slots per leader, for instance, that would also fix something. Downside, does not provide finer grained slot time for market makers and so on. So yeah, if we can go down with block times, why not? Good. Impact. App developers get faster slot level feedback and lower latency, but should stop assuming that 400 milliseconds times slot is a stable wall clock conversion. So yeah, that's for you devs, because we've always said a slot is 400 milliseconds, and that has been always true until today, 7 in the morning. When it's no longer true. It was never exactly true, but the estimate was always right. Now the estimate is wrong and is getting wronger. It will get down to 200 milliseconds. So yeah, that, ladies and gentlemen, you may change if you ever work with a hard-coded 400 somewhere. SDKs should prefer cluster-provided parameters once available. So I'm assuming there are some available, most likely. Validators get shorter window. Core contributors need to remove or audit static slot time assumptions in runtime. Yep, I hope they did. Okay, speaking of security. This is a consensus-breaking change and must be feature-gated, obviously. If that wouldn't be feature-gated, holy shit, things would break. But it was feature gated. All good. And it's still running. It's been running for 12 hours. Steady. Chugging along. Taka 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 ta. Yeah. Yeah, stay in Europe. Europe is the place to be. Yeah. Anyhow, reduced time available for leader handoff, back propagation, repair, and vote landing. The road is part of the safety mechanism. Each state should be observed under production conditions. So that's why now they're probably looking at the network a lot and being like, is everything okay? Is everything in the green? Are we good? And only then go forward with further changes. So I don't think that the next feature gate in this list already has an activation date, because they are now gonna be checking that intensively. This one, for instance, it's not activated. I can also not really see like when it's scheduled. Feature gate tracker schedule. The reduced slot time to 300 milliseconds. They're already live on testnet and devnet, and they're in Agave version 4.20 beta 1. Well, so is the other one. So maybe they are scheduled. Honestly, I don't know. But if something would be going wrong and they would see that the validators wouldn't handle it, or the leaders are just being too slow, or whatever they would observe, you can be sure that they would reschedule it and not let the next feature activate. So yeah, I trust that they are doing this carefully. The proportional reductions are required to avoid accidental increasing per second execution, right, allocation, and shared budgets. Shorter slots would increase validator resource requirements. Right, that's the thing. Because obviously, if you're suddenly having twice the transaction load in terms of CU, then you need at least twice the resources, like hardware resources, and they don't want to blow up those at the same time. It's already that they need to be faster. That's already enough stress for the validators. Don't make them have to do it faster and do more things. That's why they scaled those. But yeah, as we saw, those limits are being raised separately from the slot times. Failing to scale slot per year could change issuance. Yeah. Validators must not enforce a reduced thread limit during a feature 1 delay period. Doing so could cause turbine to shred fetch filtering. So yeah, that's for the change. But we managed to survive one change, so that's fine. Great. Drawbacks, well, obviously it's going to be harder for the validators, also for indexers and for clients to pick the right leader because they're changing faster. Validators have to pay more for vote fees. That's what I mentioned before. So yes, that's true apparently. The Alpenglow VAT is scaled, so that's not the issue, but Alpenglow is still not live. Also, the gossip traffic for votes is obviously doubling per time. Same reasons why you pay more fees, because you gotta vote more. And because the block hash, that also affects devs now, because the block hash and status cache max entries are not changed. Any client-facing behavior measured in numbers of slots may become shorter in walkout time. We don't have more block hashes to stay a valid block hash, which means also the time a block hash is valid is being halved here. And that's relevant for devs again, for you and me. We're all devs here, right? We once had a good minute, and now it's, wait, how much was it actually? Block hashes sysvar, how many do you carry? 150. We have, a minute. We had a minute, and soon it will just be 30 seconds. With 200 millisecond block times and 150 blocks, we get to 30,000 milliseconds, therefore 30 seconds that a block hash is valid. So that could break applications. If you are getting a block hash with finalized commitment and you're taking your time before you send your transaction, chances are that the block hash might not be valid again. This is one thing that you need to consider. No gains without trade-offs. Faster confirmation times, but therefore faster expiring block hashes. But for most applications, it should be fine, and you should still have enough buffer. 30 seconds is a long time when it comes to Solana on-chain blockchain computing. I mean, it's still 150 blocks that you can build in that time. But you gotta request it from the RPC, do something with it, pack it in a transaction, sign it with all the signers, and then send it. It's not forever either. So keep an eye on your apps that they're not breaking now with block hashes expiring quicker. That's certainly a drawback. Yeah. And that's as deep as I want to go. Things are changing. It's fun. We're at 350 millisecond block times and Solana is running. Like, this is a cool thing. I like this. I really enjoy this. And we're gonna not stop here unless things are breaking, which I don't expect. So yeah, it's a cool SIMD and we see it in action, and I can't wait for more of those features getting activated. To recap, breaking changes on Solana. Slot times are being reduced from 400 milliseconds to 200 milliseconds, in 4 iterations with 50 milliseconds each. And we're currently, as of August 21st, 26, what's the year? 2000, August 21st, 2026. That took me forever. We are at 350 milliseconds. What does it mean for devs? Confirmation times are getting smaller, but also block hashes are expiring faster. It doesn't change any of the limits in terms of how many CUs we can pack per time, because that scales with the block times, but there were recent increases on that. So overall, we're gonna see how this develops. I'm pretty confident that also mainnet will hold steady and not have any issues with the decreased block times. They tested it on testnet and devnet, admittedly smaller clusters and less load and lower stakes, but I don't think they do any of those changes. See, now I say they and not we. I don't think we do any of those changes without being pretty confident that nothing's gonna break. But of course, the network has halted before. I don't think that that's gonna be the case for the next halt. I actually don't think there will be a next halt, especially also with Alpenglow coming out, but I cannot guarantee it. But I do enjoy faster slot times, because that just means that trading will become even faster and overall the network will become more secure in terms of censorship resistance, because individual validators get smaller time slots. Although that's a big statement. I'll take it back, because there's more important things for censorship resistance. But overall, I would say this is a very good thing. I do like to see slot times being decreased. Toli has been talking about that 2-3 years ago, and now it's finally happening. So I like that. Next up, multiple concurrent leaders, right? Right. And next up here on this channel, I've got other videos to watch. You can give this one a like if you enjoyed it, a quick little rant, subscribe if you haven't done that already, and then I will talk about more content for Solana developers, and I will see you in the next video. Until then, take care and check out the 350 millisecond block times live on mainnet.